Hi everyone, we're looking at how to do multiplication and division with numbers that are written in scientific notation. So for the first four we've got multiplication, the next four we've got division. For the first one here, you'll see there's different symbols we're using for multiplication. You'll see a times symbol written as an X, and you'll also see it written as a dot. Just remember that means the same thing. It doesn't make a difference how we write it. So what we're going to do here is we're going to use the property of the commutative property to rearrange these pieces. It's going to look like this. So we actually don't need the parentheses because it's all being multiplied. So I'm going to make all my times signs into dots. So 5 times 10 squared times 1.3 times 10 cubed. I've just dropped the parentheses, made the x times signs into dot times signs. Then we're going to use the commutative property to rearrange these things. So we're going to take these pieces, putting them in a different order to make it easier to work with. Again, this is called the commutative property, because it does not matter the order in which we're multiplying. So we're going to multiply the first two the numbers in front first. So 5 times 1.3, and I'll put the powers of 10 second, because we're going to multiply the powers of 10 using exponent rules. It'll be a lot easier to multiply in that way than any other way we do it. So we're going to take care of the 5 times 1.3 first. So off to the side, you can multiply these. I'm going to put the 1.3 on top and then the 5 in the bottom. You could use a calculator for this as well, but you might as well practice multiplication of decimals. So 5 times 3 is 15, 5 carry the 1, 5 times 1 is 5, plus 1 is 6. But it's not 65. You got to count the number of decimals you have in your two numbers total. There's one decimal, so there's one decimal in this answer, this product. So 5 times 1.3 is 6.5. And then for our powers of 10, we know how to simplify these. We're going to use the exponent rules there. If you're multiplying a number or a base, the same base, with different exponents, the same exponents, doesn't really matter, you just keep the base and add the exponents. So we're going to keep the base of 10, add those exponents, 2 plus 3. And these two are still being multiplied in between. So it's 6.5 times 10 to the 5th. And that's our answer. It is actually scientific notation because 6.5 is between 1 and 10. So we are in scientific notation because you have a number in between 1 and 10 times a power of 10. Remember, it can be 1, but it can't be 10. When I say between 1 and 10, it can be 1, but it can't be 10. All right, moving on to some more examples here. Number 2. Very similar. We're going to go a little bit quicker. So we're going to rearrange the numbers 8 times 8.1 times 10 to the 5th times 10 to the negative 3rd. And you'll notice here I use the times sign as an X. Instead of using the other times sign, it doesn't make a difference. We're going to multiply 8 times 8.1 just to save a little bit of time. I'm not going to show the steps out for that. 64.8 would be that product. And then for multiplying these powers of 10s, we're going to do keep the base of 10, and again, just add the exponents. 5 plus a negative 3, which is 64.8 times 10 to the second. But we got to be careful. This is not scientific notation. Why is this not scientific notation? Well, the number in front is not between 1 and 10. So we're going to ignore the 10 squared for a second here and look at just 64.8. How would you make that scientific notation? Well, you got to move the decimal so it's in between. So the number we get is in between 1 and 10. So that would be one move to the left. So that would be 6.48. So 64.8 is actually 6.48 times 10 to the number of moves. One move. And it's a positive one because you've got a big decimal or big number here, not a small decimal. So just to kind of reiterate, this number here is equal to this. If we just ignore the times 10 to the second for a second here. Okay, now we're going to bring that back down and then combine our powers of 10. So this is really, the full answer here is 6.48 times 10 to the 3rd. And there's our answer written in scientific notation. We had to use one more power of 10 there in order to make that 64.8 into a 6.48, because it's got to be between 1 and 10, and it can be 1 and it can't be 10. Okay, there's two examples. Let's do a couple more. So we've got for this one, again, let's rearrange using our commutative property. 2 times 8 is 16. These 10s would make 10 to the 12th by adding their exponents. 16 is too big. We got to make it in between 1 and 10. It'd be 1.6 times 10 to the 1st. 16 would be this. We're going to bring down the times 10 to the 12th. Then we'll just combine those powers of 10. So 1.6 times 10 to the 13th would be our answer for that one. And for number 4, very similar. We're going to do 7 times 4 times 10 to the 3rd times 10 to the negative 2nd. 7 times 4 is 28. Combining these powers of 10, 3 plus negative 2 would be 1. 28, though, is not scientific. 2.8 times 10 to the 1st would be 28, written in scientific notation. Bring down the other times 10 to the 1st, and you get the answer in scientific once you combine those powers of 10. Times 10 to the 2nd. 2.8 times 10 to the 2nd. Okay, that's how we multiply. Basically use the commutative property here, rearrange the pieces. That way you can use the exponent rules on powers of 10, and you can do the multiplication of the numbers in front kind of separately, keeping it easier. Division just obviously works backwards. So we're going to look at the next few here, which is use division. So we're going to split this up, again, using the commutative property, but a different way. We're going to split this up as 1.4 over 2 times 10 to the 3rd over 10 squared. Because if you were to multiply these two fractions, how would you multiply them? Well, you'd multiply across the top, and you multiply across the bottom, which is why we can kind of go backwards here and write it in these two separate fractions, because it's actually going to be easier with two fractions. Okay, so then we're going to do each division separately. Like we did the multiplication separately up here of the numbers out front and the powers of 10, we do the division separately of the numbers and the powers of 10. Very, very similar. So 1.4 divided by 2, if you use your calculator or do it in your head, think about it as 14 divided by 2 and then just put a decimal in there, basically is how that works. So that'd be 0.7, 7/10. And then for our division rule, if you think about this off to the side here, this is really 10 times itself 3 times, and there's 2 on the bottom, so how many 10s are left? Well, 1 and 1, 1 and 1 cancel. There's only 1 power of 10 left, which is why this is times 10, or 10 to the 1st, because we subtract the exponents when we're dividing. That's our division rule there. We keep the base, subtract the exponents. So this is not scientific though, because 0.7 is too small. Got to be between 1 and 10. 0.7 is not. So again, like before, we're going to rearrange or rewrite this one in scientific notation. So 0.7 is equal to, I'm going to put it underneath actually, that equals, if we move the decimal 1 time this way, it'd be 7 times 10 to the negative 1. In order, because it's a very small decimal, you got to use a negative. Then we're going to bring down this 10 to the 1st that was still there. Something kind of weird happens because 1 plus negative 1 is 0. So it's actually 7 times 10 to the 0 would be the scientific notation, but that's just 7 because 10 to the 0 is just 1. So that's 7 times 1. So this whole answer after all that work is just the number 7, which is kind of crazy. All right, on to number 6. Very similar over here. Let's split this up. So 2.2 divided by 5 times 10 to the 6 over 10 to the 2nd. Again, here to save a little bit of time, we can use a calculator. We can just do 2.2 divided by 5 on a calculator. That gives you 0.44 or 44 hundredths. Times 10 to the 4th. Again, if you subtract the exponents, keep the base. That's our division rule for exponents. This, again, is not scientific, though. So that would be, 0.44, if we move the decimal 1 in, that would be 4.4 times 10 to the negative 1. So this here equals that. Now we're just going to bring down the extra 10s, combine them to get our answer. So we get 4.4 times 10 to the negative 1 plus 4, which is 3. And there's our answer in scientific notation. Okay, a couple more examples just to get you guys a lot of examples to look at here. So for the next one, 1.24 over 2, if we split this up and the 10s together here, 1.24 divided by 2, probably do that one in your head, 0.62, because 12 divided by 2 is 6, 4 divided by 2 is 2. And then we, again, use our division rule over here, subtract the exponents, it'd be third. This is not scientific. It would be 6.2 times 10 to the negative 1. Bring down the other 10 to the 3rd, combine them, and you've got it in scientific. just by adding again those exponents, the -1 and the 3, since we're multiplying with the same base. And one more over here. That z should not be there. You can go ahead and just ignore that z. Okay, this is 7.4 divided by 2 times 10 to the -3rd divided by 10 to the 4th. Again, if you divide the numbers out front, 7.4 divided by 2, you get 3.7. And then for this one, it's kind of weird because you got a smaller power of 10 on top, which is, it's not that weird, it just looks a little bit funny. It's the same idea though, just keep the top exponent, subtract the bottom one. It'll just be a negative exponent. So we got 3.7 times 10 to the -7. And guess what? We're actually done because that's in between 1 and 10. We don't have to rewrite that one like we did the other ones because it already was in between 1 and 10. The other ones were 0.62, 0.44, and 0.7. They were too small. So that's how we do multiplication and division and get our answer into a scientific notation at the end by just moving that decimal one spot to the right or the left depending on what form it looks like.